Hey there, Year 11s. Doing the last video, Exercise 6J examples. So these are application questions. This is for Tuesday's SAC. And with application questions, the hardest part is to model the expression first. After that, everything else is easy. You just use your CAS calculator and do what I've taught you so far. Define, solve, factor. Trying to answer the question from the graph as well. That's the aim. So I'm going to do a couple of examples just to get you rolling and feeling prepared for SAC 2. Okay, so we're going to start off with example 3 or question 3, only because I did this in class and there was a video on the first one. So if you can do the first one, you can do the second one. Yeah. Let's have a look at 3. So here we go. We're going to start off with the new page. Maybe we'll do a new page. Right, here we go. Let's do question 3. So I normally try to draw the problem first before I do anything. So the outside surface area of an open box. Okay, so as soon as I see that, I'm like, all right, I've got an open box. Some kind of box, right? It's open. Open meaning that you can see parts of the inside. Okay, so it's an open box. And surface area meaning the area on the outside of the box, they all add up to, so total surface area is equal to 75 squared centimeters. All right, so that means you need an equation already for the total surface area. That's the first thing I notice. And it says the base is a square with each edge x centimeters. So that means here, the length to this length is the same. That's an x and that's by x. Okay, they haven't told us the height. They said let h be the height. Okay, so this is my box so far. I've got my box. I know the total surface area is 75. So it says find the surface area of the box in terms of x and h. So A, this is the hardest part. And work with it. Work with what you've got. See, draw the problem. Now, how do you find the surface area? Remember back in year 7, 8, and 9, to find the surface area, you've got to find the area of one side, then you find the area of another side, and you find the area of the other side, and you find the area of the other side, and you find the area of the bottom side. You add them all together, that's your total surface area. Yeah? So this is what I'm going to do. I'm going to do the area of this side first. So I'm just going to do this one. And I can say that's a length of x by a height of h. So if I were to find the area of this green shape here, I would say the area for this one is x multiplied to height. But remember, you can also have the backside, which is exactly the same as well. So that's now times by 2, right? And then if you think about the side on this end here, because it's a square, it also ends up being x multiplied to h as well. So this rectangle, or square, or whatever you want to call it, that also is x times h. So that's a third one, and that has a backside as well. There's a backside over here, and that's another one with x times h. So technically, you've got 4 of these x times h's instead of 2. Yeah? So back, front, left, and right. Then finally, you got your bottom area. So area B for bottom. It's x times x, which is x squared. So if you sum all of these together, it should give you the total surface area. So if I write it out, total surface area has to equal to x squared plus the total area of the other 4 pieces, which is x times h times 4. So 4xh. Okay? And that's my expression right there. That was the hardest part. Then it says, hence find h in terms of x. So what you want to find now is just h, where it's in terms of x. Okay, so you need some sort of equation, some of the information they've given you, so that you can find h, or write h in terms of x. And this is where you look at your piece of information. The only one that I haven't used so far is this, the 75. See, the 75 tells me the total surface area is 75 here. I've got an x squared plus 4x h. My goal? Well, my goal is to find out h. So to find out h, I have to remove everything else. So I'm going to move the x squared across. So that's 75 minus x squared is equal to 4 times x times h. But then if I want to get h, I got to remove the 4x. Now they're all times. So the opposite of times is divide. So I'm going to have 75 minus x squared and divide that by 4x. This is my h. Okay, that's my h there, and that's really answering part B. Part B. Okay. Now I've got my h. I've got my part A, part B, and now it says C, find the V, which is the volume of the box. Now we know volume of a box, the volume has always been length times width times height for a box, right? For that particular box anyway, that's a square-based box. So in our case, our length, we already know that was x. Our width, we also know was x. And our height, well, we didn't know, so we called it h. But they did say find the volume in terms of x. That means I don't want to have this h. Okay, I don't need this h in the volume formula. The problem is, how do I not have the h but only have x's? This is why you did part B. See, B, you can replace this h over here. You can say, all right, well, that becomes x times x, which is x squared. Multiply instead of h, you now have 75 minus x squared over 4x. Okay, and if you simplify this, this becomes x squared multiplied to 75 minus x squared on 4x. Okay, this is my volume. And that is my volume equation in terms of x. They only have x's in there. Okay, so that's part C. Now, D, it says find the volume when x equals 2, x equals 5, x equals 8. Now, at this point here, I would stop doing it by hand. Once I've got the equation that I want, it's pretty easy here. You know, D, if you want to know when x equals 2, yes, you can sub 2 in, and you can try to solve it by hand. At this point, I'd use a CAS. You know, at this point, I would say define, so menu 1, If you haven't watched all the other videos, like cubic revision, watch those videos. I go through how I do all this again, how I use my CAS, yeah? Watch that cubic revision solutions, watch that video, okay? So I'll do it again, define v of x or f of x, whatever you want to call it, yeah? So I'm doing v of x is equal to x squared multiplied to bracket, control divide, which gives me that bracket there, 75 minus x squared divided by 4 times x. Is that right? Yes, that is correct. Okay, now I've got my v of x, and I want to substitute x equals 2. So all you have to do is just do v of 2. Bam, 71 on 2. So v will equal to 71 on 2. And so this is I, when x equals 5, you know, you don't have to do all this by hand here. This will be tedious. In your SAC 2 on Tuesday, you know, do it on a CAS. So x equals 5, 125 on 2. If they ask for decimal points, remember you can bring your cursor up, move up and down, highlight that, press enter, and then hold control. So press the control button and then press enter, you get the decimal points. Okay, so you convert an exact value to decimals. So if I don't ask for decimals, you got to give it an exact value. This is called exact value. Okay, if I ask for decimals, give me decimals. 62.5, right? They didn't ask for decimals? No, they didn't. And then x equals 8. So 1, 2, 3, x equals 8. Volume v is equal to, and same thing again, v of 8. Whoops, v of 8. And bam, 22, right? So 22. Pretty easy. Then you go to E. Now E is pretty straightforward as well. It says given that v, so the volume now, you know the volume is 59 when x equals 4. Find the other value of x for which v equals 59. So that means that there are two parts where it equals to 59. Now, you know that the volume equals 59. You're trying to find other possible x values. True? Now, because this is potentially a cubic graph, it's likely to be a cubic graph, sorry, because we're in cubics. It might mean that you have two intercepts where it's 59. So it could be something like this. It crosses through that point and that point. So when x equals 4, you know, the y value is 59. So you got this point is 59, and we don't know what this x value is to make a y value 59, right? So same thing. All you have to do is sub in v and then solve for x to find out your x values. That's all you have to do. You got your v equation, so you now have 59 is equal to x squared times 75 minus x squared on 4x. Now you can try to do this by hand. Yes, you can. I'm just saying you can use your CAS at this point. Yeah, so we're doing our CAS. We're trying to solve. So menu 3, 1, if you've forgotten how to do it. Menu 3, 1 gives you solve. and I'm trying to solve for v of x to equal to 59. Okay, because v of x is my equation. I want the equation to equal to 59. I don't know what x is, and I want you to solve for x. So comma x. Press enter. And it looks like you got quite a number of answers here. You got x equals 4. Okay, I'm just going to copy paste this. Whoops, let me do it again. X equals 4. So up to this point here, you got x equals 4, which they already told you already. In the question they said x equals 4, but they want to find other values. So the other possible values were x equals 2. Now that's a negative 3 root 7 minus 2. Or you can have this one, which is when x equals to 3 root 7 minus 2. Now here's the thing, because it's in exact values, you can't tell from the decimals. I'm going to change these to decimals here. So I'm going to click here, I'm going to highlight again. Press enter, control enter. Now I've got my decimals, negative 9.93. This is negative 9.93725, and this is 9 point likely to, no, it's not 9, it's 5. 5.93725, okay? So, yes, you did get 2 answers, but remember, you have to think in terms of volume context. This was an open box, and x represented the length of a base. Now, logically, how is it even possible to have a length of negative 9.93? That doesn't make sense. So we know that since x has to be bigger than 0, it has to be a positive number. Since the length of the box, the base of the box, okay, is x, it has to be bigger than 0. We can't have that as an answer. Therefore, the other answer is 3 root 7 minus 2. Okay, centimeters or whatever it is. But that's the answer. If they ask for decimals, which I don't think they asked for decimals, no, they didn't, then you would write it as 5.93 or 5.94, okay? But because they didn't ask, I'm going to leave it as my exact values. How was that? Was that pretty easy? Yeah? Okay, let's find another problem. I'll do one more, just so you get a good, something different. So that's another box there, question 6, and the only one that looks a bit different is question 5. So let's do question 5, yeah? Let's do question 5, and that should be enough for you to feel comfortable. Remember, it's all about looking at the problem, applying the problem, using your CAS. Yeah, where you can use your CAS, use your CAS. That's what I've been emphasizing, yeah? So here we go, let's have a look. Question 5A. Actually, no, let's look at the diagram. We've got a diagram that shows a conical heap of gravel. The slant height of the heap is 8 meters, which in the diagram, that's the slant height, yeah. The radius of the base x is okay, yeah. And the height h. All right, cool. So express x in terms of h. Now, when I see this, the first thing I notice is this is a triangle. And that is a right-angled triangle because it's from the top and it comes all the way vertically down. That's the height, yeah? Otherwise, it'll be a slant rather than a vertical height. So because I've got a triangle and I draw it out, I can already see this is 8, that's 90 degrees, that's h, that's x. The only thing you learnt in year 9, well, there's only 2 things in year 9 that is related to right-angled triangles. One was SOHCAHTOA, trigonometry, or trigonometric ratios, or Pythagoras' theorem. Those are the only 2. Now, they haven't given you any angles. There's no angles here. So it has to be Pythagoras' theorem, right? Pythagoras' theorem, if you remember, it was c squared equals to a squared plus b squared. I needed to form an equation. That's the problem. That's the hardest part in A. You need to figure out how to form a problem. That's hard. That's where application gets hard. Once you got the equation, it's easy to do the rest, you know, to do E, to do F, to do, you know, find the maximum. All that is easy. It's the first parts that you got to really work on for applications, yeah? So in our case, our hypotenuse is 8 squared. I don't know the rest, so h squared plus x squared, and this gives me 64 equals h squared plus x squared. But remember, I'm trying to find x in terms of h, so I need to solve for x. So I'm going to move the h squared across by minusing h squared. So 64 minus h squared is equal to x squared. But remember, I don't want x squared, I want x. So you got to square root both sides. Now when you square root, remember every time you square root, there's a plus and a minus answer. But what we know is x represents the radius. See, x is the radius. So it doesn't make sense to have a negative answer already. So therefore, x can only be the positive root of 64 minus h squared. It can't be a negative. It has to be a positive outside. If it was a negative, then it doesn't make sense. You got negative radius. Okay? So this is my expression. That's part A. I got A. Okay, x equals to root of 64 minus h squared. Now it says the next part, construct a function which expresses the volume of the heap in cubic meters in terms of h. Now this requires you, because it says the volume of the heap, which really is the volume of this shape, you have to know the volume of a cone. If you don't, search it up in Google. Okay, hopefully you still remember from year 8 what the volume of a cone is. It would be V equals to a third of the base area or the cross-sectional area times by the height, which is that. Okay, but we do know what the area is. This is a circle. The area of a circle is pi r squared. So what we have is 1/3 times, not pi r because the radius is x, so it's pi x squared now times by h. What I find interesting is they want it in terms of h rather than in terms of x. So in this case here, remember it says find the volume of the heap in terms of h. It means that it doesn't want to have any x's. And in my equation right now, I've got an x. I don't want x's, I only want h's. And the reason why in part A, they wanted you to find this relationship between x and h is you're going to replace the x where the x's are. Most application questions always do that. Yeah, they're trying to guide you to solve the problem. In year 12, they won't guide you. You're just going to have to figure it out yourself, what you need to do. But in year 11, they guide you. So they say, rewrite the equation x and h, and now find out the volume. So we've got pi times, instead of x squared, it is now root of 64 minus h squared, all squared. Yeah, because I'm replacing the x. Yeah, I'm just going to highlight what I just did. I just took this x and I replaced this x. So that's my x there. True? And it's x squared, so I've got root 64 minus h squared. But the nice thing is, hopefully you picked up as well, the square and the square root will cancel out. And then you've got times h on the outside. Okay, I'll do that in red so you don't get confused. Times by h. So really, if I simplify things down, that's 1/3 times pi times 64 minus h squared, because the square roots got cancelled out with the squares, and times by h. This is my volume equation. Okay, once I got my volume equation, from here on, this is all easy. I would define it. Because the next question says, use the CAS calculator to help draw the graph of V. Right? So what I would do here is I would I would define the graph. From here, I would go to the CAS. I'm going to remove all of this again. So I would say define f of x, I'll call it v of x, equals to 1/3. So here we go. Control, divide 1/3 times pi is over here. There's your button, pi. Multiplied to, what was it again? That was 64 minus. Now, because instead of h, I've already defined it with an x over here. I have to use x's. Okay, so 64 minus x squared multiplied to x. But in this case, x represents your h, yeah? Not the x in the diagram. Okay, I'm just making sure you understand. The reason why I have to use x is because when you graph it, the calculators is always in x-axis and a y-axis, so you need x values. That's why you have to use x's. Okay, so there we go. I've just copied this. I've just replaced the h with an x. Okay, there we go. This is my graph. I've defined it, and they want me to sketch. Now again, remember you can do Control Doc, which add a page, and you go to Graphs, number 2. And type in v of x. Now, remember, I only taught you 3 ways to rearrange the graph so that you can see it better. Now, notice it's too big. You can't see the graph, right? Now, I'll show you the 3 ways again. I always go to Menu, 4, Zoom Fit, which is the last one. It's A, okay? Zoom Fit. If I do that, in this case, most times they don't come out nicely. Okay, in this case, it did. When it doesn't, I use Zoom Box, and then I go to Windows Settings to adjust it. So these are the only 3 I use. I use Zoom Fit, Zoom Box. Sometimes the height's too big, so I use Zoom Box to get in where I want. and then I do the final settings where I manually adjust it. Okay, but in our case, it looks perfect. So now we can see what it looks like, and they ask us to sketch. Now, this is the mistake a lot of students do in a SAC question. Where's my pen? Okay. In a SAC question C, they ask you to sketch it, and students will do this. They'll go, all right, let's copy the graph. You got, this is your v-axis, which is your volume, by x, and they'll look at this and they'll go, okay, cool. Here we go. Comes up and down. Okay, and they now and leave it like that. That's a bad thing. That's one they're not labeling. You need to label the axis intercepts here. So hopefully you figured out you can still go menu, analyze. Let's find the x-intercepts is number 1 for 0. And we can do left in there and the right. So it's -8, 0. Do it again. Menu 6, 1 for 0 again. Clearly this is a 0, but let's just double check. 0, 0. Menu 6, 1 again. And then I'm going to just move this over here. And okay, so it's -8. Whoops. Come on. There we go. -8, 0, 0, 0, and 8, 0. So I know -8, 0, and 8, right? And they sketch that and they're like, done, right? No, that is absolutely not correct. So from here, remember, you're sketching an application problem. It doesn't make sense already to have negative height. Remember, this x value actually represents your height. Yeah, I've just replaced the h with an x, but you can't have negative height. It doesn't make sense to have a cone with negative height. And at the same time, it doesn't make sense to have negative volume. So none of these here are going to work. And you can't have any negative x's. So none of that's there. The only part that you actually do sketch is this part of the graph. And I'm going to do it in blue now. What you should be sketching in the exam and your SACs is that you've got your axes and you only sketch this part. Only from here to here. Okay? And one more thing, volume of a cone cannot be 0, so you have to use an open circle at the end. Okay, so for a perfect graph, it should have looked like this. 0, I mean not 0, it's open circle. So that's at 0, and this is at 8. And this is my v-axis by h graph. Okay, there you go. That's what C should really look like. Okay, so don't make that mistake. You really got to analyze what you're actually doing. That's why applications is tricky. Yeah, and the rest is easy. So if you have a look at D, you know, it says find the value of the volume if h is 4. So really it's just saying if h is 4 or x is 4, then you just do v of 4. There you go, 64 pi, or decimals, 201 and 062. Yeah, so this one is 201.062. The next one, find the values of h when the volume is 150. So now that you know the volume, see, this is the volume. If that's 150, you're really just trying to solve for h. So this is where I go solve v of x, and I know the volume is 150, but I want to solve for x, which remember it's your h. Yeah, I replaced it. And there you go. Now you got values here. Now which one of those is likely to be correct? Okay, now we know that h cannot be a negative, and from our graph before, remember when we sketched it, it was between 0 and 8, so that means you got two answers. You got 2.47 and you got 6.47. Those are your two answers. Okay, so answering E, h will equal to 2.475. I normally take about 2 to 3 decimal places, unless the question asks. Did it ask for decimal places? No, it didn't. And if you want exact values, which I'm surprised it didn't give me exact values here, menu, you can go to Document, Settings, Document Settings. Yeah, it's on calculation. See, calculation mode is in auto. If you want exact values, you got to change it to exact. I always keep it on exact because in your year 12 exam, if they don't ask for decimals, you don't give it in decimals, okay? So that would be wrong to do that. So I'll do it again. I'll highlight it, drop it down, press enter. So I'll do it again. Just so you know, I move my cursor up, highlighted it, press enter, and I do it again. But now the calculation is in exact, and oh my God, that's terrible. Okay, you know what? Stick to decimals. I mean, it's not a year 12 question, so I guess we'll just answer this particular question with 2.475 and 6.47. Okay, h equals 6.47. those are the only two that you will get a volume of 150. Okay, and then what was the last question? That was E. So you got to no, actually that was F. Sorry, I just did F. Now G, find the maximum volume of the cone and the corresponding value of H. So really, how do you find the maximum of volume? Just go back to your graph. Oh, where's my graph? This is my graph. Yeah, maximum volume has to be somewhere over here. That's my maximum up here. True, because remember the graph was between 0 and 8, so the maximum has to be over here. And remember in analyze, so menu, analyze, instead of 0 for the x-intercepts, you got 3 for maximum. Maximum, so it's about somewhere over here. So I'm just going to do left bound and the right bound. And there you go. So when the volume is 206, remember the y value is your volume and the x value here is your height. So when the height is 4.62 meters or centimeters, I can't remember, meters, and the volume is then 206 cubic meters. There you go. See, so what was the hardest part? If you really looked at all this, I just did D, E, and F, G just with the CAS, right? Oh, actually, no, I haven't done D. Sorry. D, state the domain. Domain is like what the x values logically should be. Now, if you sketched it appropriately, the domain is clearly between 0 to 8. Okay, so you would say x is bigger than 0, but less than 8, but not equal to. Yeah, because you can't have length of 0 and you can't have a length of 8. Because if the height is 8, okay, then the volume is 0 and you can't have 0 volume. Okay, so answering D just from your C graph. So question C, so this is moving from, it's 0 to 8. There you go. And you know, it's like C was sketching from your calculator, D looking if you're applying the knowledge of the application, E, F, G was all CAS. The only hard part is A and B. That was the only time I really used a bit of algebra here, yeah? See, this is when I used algebra, and this is when I used algebra, A and B. And that's always been the hardest for application questions. Okay, that's what you want to do in your SAC. You want to be able to draw the problem, and really the hardest part is getting that expression. Once you get it, hopefully I've taught you well enough with your CAS skills. There's only a few skills that you're really doing over and over. Okay, so make sure to watch all the videos there. Good luck, enjoy the weekend, and that's it. Thank you. Uh-oh, here we go.